In the true and false question number 4, the vertical asymptote of the graph of f of x 1 over x plus 5 is x negative 5. So first of all, you know that the vertical asymptote is always the number on the denominator. So you need to find for x, equaling it to 0, and your answer will be x equals negative 5. So in this statement, you know that it will be true.
In procedure question number 2, we are looking for the domain, the vertical asymptote, horizontal, coordinate of all, range, y-intercept, and x-intercept. We will start by expanding our equation in the denominator, which would be x plus 3, x minus 3. Obviously, all of this is below 3. Now, we will start by the vertical asymptote, which would be by solving the x of the denominator. This will give us negative 3 and positive 3, and we will plot this in by putting these lines on the asymptotes. Now we will solve for the horizontal asymptote, which will give us to 0 because here we have a degree of 0 and here a degree of 1, which means this one is bigger than this one, which will give 0. Now the coordinate of a whole, it would be none since there is no cancellation. Now the x-intercept, it would be 0. This is because in here we have no x in the numerator. And the y-intercept will be equal to negative 1/3 because in here we will plot in on the original equation a 0 on the x, which will give us 3 over negative 9, and by simplifying it, negative 1/3. And now we will start by plotting these values, but first we will do a table of values. First, on the negative 4, the negative 1, the 1, the 4, the negative 6, and the 8. These numbers we chose them because they are before, during, and after the asymptotes. Now, the negative 4 will give us 3/7 if we plot it in on the equation, the negative 1, negative 3/8, 1, negative 3/8, 4, 3/7, negative 6, 1/9. Now, we will start by plotting on here the 0 because of the horizontal asymptote. Then, because of the points we got, we will plot them on our equation. And here we know it's a down function because of the points we got. Now in this one, we know it's up to here, and it goes this way. And in this one, we know it's here and here. And we plot it like this. And now with this, we can know the domain and the range. The domain will be all real numbers except for 3 and negative 3. And the range would be all real numbers except for 0.
In the procedure question number 3 of the quiz, it says to evaluate the following piecewise function. We are given 3 piecewise functions. The first one states that at x squared minus 1, the x has to be less than negative 3. In the second piecewise function, the x of 5, which we don't have an x, would be greater than negative 3 and less than 4. And in the last piecewise function, the x of 4x plus 2 has to be greater than 4. So the function that we have here is f of negative 6. So what we need to do is look in these piecewise functions and check in which one the negative 6 would be located. So let's check in the first one. Let's see if the negative 6 is less than negative 3, and that is true. So now that we know that the negative 6 is in fact less than negative 3, we need to plot the negative 6 in the x of this piecewise function. So we will do negative 6 inside of a parenthesis, and you do squared minus 1. So f of negative 6 equals 36, and you don't have a negative since it's squared, and negative equals positive. So 36 minus 1 equals 35. So the complete answer would be f of negative 6 equals 35.
The horizontal asymptote of the graph f of x equals negative 1 over x plus 6 is at y equals negative 6. This statement is false since To find the horizontal asymptote, you first find the zeros of the numerator. And in this case, the numerator has no zeros. You can see here it's -1. Therefore, its vertical asymptote is y equals 0 and not y equals -6.